this. Michael, just looking for yours. You just take your time. There you are. Yes. There's not enough room? Okay, we'll just make more room then. Yeah. Yeah, say it's over there in the middle of nowhere. Sure. If you don't like it, you want to put more space? Oh, that's fine.
I'm just wondering because if you put it there, it wouldn't be at all.
Okay, yeah, it's fine. I understand what you're saying. Yeah, if there's not enough room, just tell me how far you want to put it on the one side. If you think that the number 2 is not written properly for you or whatever. And then there you go. Christian. There you go. Ryan, here you are. Enjoy. In. Oh, almost. Close enough. Carson, front row. Sign. Lady. Eli, there you are. Enjoy. All right, hopefully you're coming down the home stretch with this thing. So if you are done, feel free to pass it over so that I can come collect it. If not, we will. I will be patient, at least for a little bit. Wow. This is not mine. Oh, this is mine. Well, there's 4 of you. Never mind, I miscounted. I don't know what I was doing. Is this for me? Sure. Is that one for me? All right, I'll take it. You're happy with it? Close enough? It's too easy? Good job. There you go. Good job. Nice work. Enough. Yeah, I'll take them. Why not? Great. Yeah, you have something for me? I'll take it. I'll turn it around when I get it. Yeah, beautiful. You sure? Yeah. What are you doing with that popcorn? Is that something you do with your lab? No? Okay. You don't make popcorn? Yeah, it made me hungry. Why did I do that? Oh, I know who this is. Sorry about that. There, FERPA violation. There you go. Okay, I think I've got all the quizzes now. Oh, you've got one? Good. Thank you. Now I've got all the quizzes now? Okay, just want to staple them together. Crunch. Okay, so let's see if I can do this one. So the first thing is, of course, we're computing a moment about this axis. So this is going to be 2 times, I'll just write it down here, 5, 2, 4, 6, 8, 8, that's 40. So the total here is 90. And then on this side, 1, 2, 3, 4, 5, 6. So this is 60. And then 10 times 3, right? So x equals 3. Does that work it out? So yeah, so we want to make sure it balances on the left. Apparently I didn't leave you enough room because 40 times, so if you do this side, you get 80. And then you want 5x to equal 80. So x is 16. So I can't, yeah, it's over there somewhere. Or someone had like this. Put 6 little boxes there if it makes you feel better. So sorry about that, but that's it. Okay, so we're going to be doing the same thing, but we're going to be doing it with objects like this. We have like the sine curve. Let's draw a sine curve here. Beautiful sine curve. And then a cosine curve. Cosine curve looks something like this. I know it strikes fear in your heart when you see sines and cosines, but let's say that we want to find the balancing point of this region. So it's called sometimes called the centroid or the center of mass. If we deal with masses, we would have to talk about density. And so just so you know, I will use in this class, I will use centroid and center of mass interchangeably because for me, I don't care. I know that there is a slight difference, but at least in this context, it's not going to be a big deal. So I want to know the balancing point for this, and we will do that momentarily, but first we need to understand how you do this. So this is sine, and down here, this is cosine. And so here is the idea. We'll go back to here. Nope, that's not the idea. Where is my idea? There it is. That's where we are. Is we want to find this balancing point, the center of mass of this stuff. There it is. So, so the idea here is we're going to do the same thing. So imagine that you have a fulcrum similar to the fulcrum that you have here, but it's not really, it's a point that you're balancing this on. And so what you want is you want something similar to the situation that we had on the quiz, and that is that if you were to compute the moment in any direction, you should get, well, 0 if you think of the point as being the origin, if you will, sort of the balancing point. So you want everything to balance, whether it's left, right, forward, back, everything should balance if that's going to be my fulcrum or my point, my center of mass, or the centroid. So here's how this is going to work, is we're going to imagine this object, sort of this flat object. I'm going to go back here because it's easier to think in terms of this. I'm going to break this up, as is our tradition, break it up into little rectangles. So let's go ahead and draw a rectangle on here. Oh, come on. That's one rectangle. That's a terrible rectangle, so I'm going to draw another one. I'll try to do a better job. That's a little bit better. So those are my rectangles that I'm going to use as stand-ins. So here's the plan, just so you know, as we move forward. The plan is I'm going to figure out what the center of mass would be as if this were made up of a bunch of rectangles. And then I'm going to do a limit. So you know the drill, right? This is what we do in Calculus 2, is we make a, approximate using rectangles, and then we use the magic of the fundamental theorem of calculus. So imagine one of these little well, here, first of all, what's going to happen is let's do the moment about the y-axis to start, okay? So the moment about the y-axis is going to be the distance from the y-axis. So you have the distance from the y-axis. So let's see, how is this going to shake out? Which is the x value, right? So we have the x value times, why is this not working out? Oh, mass. Sorry, that's my problem. Is I need some stand-in for mass. Okay, sorry, I've got distance. I'm just, sorry, blanked for a minute there. I think I saw someone with a cowboy hat on. What's he doing out there? Can't see him, he's gone now. But it's just like, just kind of, what's going on? Okay, so let me remind myself, this will help me, is that you have a moment is going to be the sum of the distance times the mass. So that's what we did on our quiz, right? You took the mass times the distance and added them up. Doing the same thing here. Sorry, it took a minute there for me. Okay, so mass times distance, distance times mass, and so on. So for this, as a stand-in for mass, I'm going to use area. And the reason for that is because if this thing were made of some constant density, think of a piece of plexiglass or I don't know, a piece of aluminum or whatever that you cut this shape out of, then you'll have a constant density, and the mass will be the density times whatever volume the little piece is. Well, and we're just going to use area instead of volume because we don't know how thick this is. So we're going to use the area instead of the mass. So x times the area, and the area in this case, x times, it's going to be, let's see, the sine of x minus the cosine of x times delta x. You knew that delta x would show up sooner or later. there it is. So there is my my moment about the y-axis. I'll be adding up a bunch of these things. So you're adding up a bunch of the x, which is the distance from the y-axis, times this, this area. Now, of course, you know what's going to happen is when we apply the fundamental theorem of calculus, we do a limit as x approaches, or delta x approaches 0. This magically turns into this integral of x times the top minus the bottom, and this becomes dx. So give me a minute here. We'll actually compute this. So I suppose I should put limits in. So let's put our limits. We all know that the sine and cosine are the same at pi over 4 and 5 pi over 4. I'm sure you knew that ahead of time. So I suppose you could have figured that out on a calculator or something. So those will be my limits. So this is the moment about the y-axis. So this is similar to what you're doing here. It's just that instead of having a fulcrum, I'm using the y-axis as my point of reference. So on the quiz, you had the nice fulcrum. You said, how far are you times how heavy is it? Here, I'm doing how far times how heavy, but the heaviness is we're using the area instead of the actual. If you had a density, by the way, you could actually use the density to figure out the mass, but we're not going to do that. Okay, so we've got that. Why don't I actually go ahead and we'll compute this. So this is going to be x times the sine of x minus x times the cosine of x dx. You know what, I prefer, you know, I'm going to get rid of, sorry, I know you just wrote that. Let's get rid of that. Because I'm going to use integration by parts. So u is equal to x, du is equal to dx, dv is sine minus cosine. I mean, you could have just done the multiplication first and then done 2 integration by parts, but I just thought it would be easier if I did it all at one fell swoop. Okay, so then this is going to be the antiderivative of sine is negative cosine. Antiderivative of cosine is sine. I know that's really little, so let me zoom in a bit so you can see what's happening. I should have made you do this, but that's all right. Well, I'll make you do the next one. The next one will be fun. Okay, so we've got that. And then this thing is going to be the integral of u dv. So notice that I have this broken up into u dv here. Is going to equal u times v, x times negative cosine minus sine. That's u times v, minus the integral of v du. So if you need to, please do review all of this, uv minus the integral of v du. Make sure you know your integration by parts. Now, notice that I dropped my limits, mainly because I'm going to pull them back in at the end. Yeah, here I regret I should have made you do all of this, but here we are. So let's see, let's write this like this, cosine plus sine. I just moved the negative out front. This, you've got a double negative, so this will be the integral of cosine, which is positive sine. And then the integral of positive sine is negative cosine. And now I'm going to put my limits back in. A little bit of a challenge to remember all of our sines and cosines, but I'm gonna try my best to do this for you and help you out. So when I plug in 5 pi over 4, I get, well, x is 5 pi over 4. That's easy enough. The cosine of 5 pi over 4 is radical 2 over 2, negative radical 2 over 2. So this will be negative radical 2 over 2 minus radical 2 over 2 is the sine of 5 pi over 4. If you don't believe me, punch it into your calculator. And then I'm going to add to this the sine of 5 pi over 4, which is negative radical 2 over 2, and then subtract off the cosine of 5 pi over 4, which is also negative radical 2 over 2. Wow, so much. Let me know if I get any of this wrong, though. Yell out. Save me from myself. Okay, so next we're going to subtract off the bottom limit, which is negative pi over 4 times the cosine of pi over 4, radical 2 over 2, plus the sine of pi over 4, radical 2 over 2, and then plus radical 2 over 2 minus radical 2 over 2. Wow, so much. Let's see if I can clean this up. So that's going to be radical 2 times, let's see, 2. So this will be 5 radical 2 pi, double negative over there, over 4, plus, that's going to just be radical 2 pi over 4. I think that I got everything, so this all is going to be 3 radical 2 pi over 2. I hope. We're going to find out, because if the answer, this is just the moment. So this, just so you know what this represents, this is when we add it up. So like when you did this for one side, think of doing it just for one side of the fulcrum. That's kind of like what this is. So it's the moment about the y-axis. Oh, I should probably put this as a formula. Give me a minute here. I think I've got it in my PowerPoint. Oh, I don't have it as a formula. Well, I sort of have it as a formula. Yeah, let me defer. Let's do the next one really quick, and then we'll go back and show you the formulas. Okay, so the next one's harder. That's the moment about the x-axis. The moment about the x-axis is going to be a similar sum, but here the sum, so let's take this rectangle right here. You have to imagine the center of that rectangle, the distance from the x-axis to the center of that rectangle, because the reason why I'm using the center of that rectangle is because if you imagine a big rectangle, its balancing point is that the middle point right there. So that's why I'm using the center. And I want to know how far is it from here to here. And the distance from there to there will be the average of these two functions. So I'm going to use the average of those two functions. So that'll be the sine of x plus the cosine of x over 2. So that's the height of that dot there, average of the two functions. And then you're going to do the same thing you did over here and multiply this by the area, which is sine of x minus cosine of x times delta x. So I think you can see what's going to happen here is that you end up with an interesting sort of combination here, that this ends up becoming the integral of sine squared of x minus cosine squared of x over 2. So I did two things there. First of all, the thing that isn't surprising is that I applied the fundamental theorem of calculus. Really, it's two things. It's a limit, turning this into a definite integral, and then we'll use the fundamental theorem of calculus a little later. But so this delta x became the dx. The other thing I did is I multiplied this times this. You have a plus b times a minus b, difference of 2 squares. So sine squared minus cosine squared. Now, to save us some pain and suffering, I'm going to apply and this goes from pi over 4 to 5 pi over 4. I'm going to apply one of our identities, and that is that the cosine, double angle for cosine, which we all know, is cosine squared minus sine squared. And so notice what I have there is sine squared minus cosine squared, which is the negative of that. So negative cosine of 2x. Just to make things a little easier on us, as we do this integral. We could do it using the formulas, the power reducing formulas, but this is a little easier. Okay, then from here on out, this is pretty straightforward. This is going to be the negative sine of 2x over 4 evaluated from pi over 4 to 5 pi over 4. Sorry about the little mess there. So just to explain, what you have here is the antiderivative of cosine is sine, that we all know. And the 2x here, if you did a u substitution, you'd get u equals 2x, du is equal to 1 or 2 dx. So I need to have an extra 2. I kind of do that in my head whenever I have a linear term inside a cosine, but if you need to, please do write out the u and the du. Okay, so now I can plug and chug this thing. So let's see, I have negative, I'm going to write it out because I'm a little bit less sure, especially with these large angles, minus negative sine of pi over 2 over 4. Interesting. Those are the same number. Negative 1/4 plus 1/4 is 0. Fascinating. Actually, it's not that fascinating if you look at the graph, but that's what I got. So what does that tell? Well, look at the graph. I mean, if you look at the graph, this thing balances along this axis, doesn't it? Yeah, what do you think, Americo? No, I did it in my head. That's why. Sorry. I could here, I'll make everyone happy just for a sec. So you're right, 2 times, so 5 pi over 4 times 2. That's what I did, and that's what I did, Ben. So that make everyone happy with the, I was just trying to do it quickly because I wanted to get to the answer. Let's get the actual formulas though, because that's what you really want to see. And then, oh, we're not quite done with this. Yeah, it kind of makes sense just looking at this picture that the balancing point would be at y equals 0, because you have half of this object is above that, half of it is below that. So that kind of makes sense, but this, we'll deal with that in just a minute. So let's put it all together. So here are the formulas that we're going to use. And this looks a little bit different, but this is exactly the same thing that we just did. Let me just point out that to find the average x value, what you do is you take that moment, this is the moment about the y-axis that we computed, and divide it by the area. So take the moment, this is the moment that we just did, and divide it by the area. So let's do this. Let's do this with an actual problem. Actually, let's finish up the sine and cosine because that one's much more fun than the one I have planned. So let's go up here. I need the area. That you can do. I need the area here, the area that I've shaded in purple. So set it up, compute it, and be happy. So I'll get you started. It's going to be an integral from pi over 4 to 5 pi over 4, but I need the integrand and beyond. All right, so we're going to blow through this pretty quickly. Darren, do you know what the integrand is? What do I integrate here to get this area? Yeah, just top minus bottom. So this is just normal finding the area. That's it. Sine of x minus cosine of x. Very nice. All right, now let's go ahead. I should have done this from the get-go. Emily, what's the antiderivative of sine? Ooh, tell me, where are you? Oh, okay. I'll come back to you. You'll get to do the integral of cosine, how about? So when you get it written. But I know Landon knows the integral of sine, right? It is cosine. Did you say negative cosine? I think you did. I just didn't hear it. Thank you. Yeah, so antiderivative of sine is negative cosine. And then Emily, do you know the antiderivative of cosine? It is just sine. Very good. I know I'm hitting you guys up super quick here, but pi pi over 4 to 5 pi over 4. That should be a 4 there. 5 pi over 4. And then now you've probably all got this memorized, that the cosine of 5 pi over 4 is negative radical 2 over 2. The sine of 5 pi over 4 is also negative radical 2 over 2. And then we're going to subtract off from that. The cosine of pi over 4 is radical 2 over 2, and the sine is radical 2 over 2. So many radical 2's, so many 2's, but I believe if you add those up, you'll have 4 radical 2 over 2, which is the same as 2 radical 2. Is that right? Any complaints about that? So there's my area. Now let's go back just briefly here, and then we'll try another example. So x bar should equal 1 over that area times this moment. That's what this is. That is the moment about the y-axis. So I need to go back here. I know it's annoying, but where was my moment? There it is, 3 radical 2 pi over 2. So let me go back here to this times 3 radical 2 pi over 2. And then y bar is 1 over the area times this thing, which is also the moment about the x-axis, times 0. So the y bar was easy, that's 0. The x bar, I've got to do a little bit of math here. Let's cancel that, and you get 3 pi over 4. So my center of mass, or my centroid, is this point right here. Let me show you where this is on the picture, on the diagram. 3 pi over 4 is right here in the middle. And so that is the balancing point. That's one way to look at that is that if you took that and cut it out of aluminum or whatever, and you threw it in the air and spun it around, it would spin around its center of mass, or its centroid. So that's where it would, that's going to be where it rotates around that point. Or that is also the balancing point. Let's do this again with another object. See if you can do it. I know this is kind of dizzying so much in such a short amount of time, but I think you can handle this. I've got two that I'd like to do. So let's do this one first. I will remind you of the formulas. So you're going to do 3 things for me. You're going to compute the area. Then you're going to compute the x bar, which is 1 over the area times the integral of x times f of x. And then the last thing you're going to do is you're going to compute y bar, which is a little bit more confusing, but it makes sense when you do the diagram. 1 over the area times the integral of 1/2 f of x squared dx. You might wonder, where is the bottom of this? Why is it not like when we did this with the sine and cosine, you had sine squared minus cosine squared? Well, the reason why there's no bottom is that this is the x-axis, is the bottom of this object. Yes, Hayden? Oh, okay. You already knew. All right, yeah. So that's why this is sort of a simplified version of the formula. So you're going to do those 3 things. See if you can do it while I get myself set up here, because there's not enough room on this screen. Go. All right, let's see where we are. Christian, what do I do to make the area of this thing? Okay, yeah, minus 0. Good, good, good. And what are the limits? 0 to 4, very good. Okay, so we're going to do this. This is easy. I'm not even going to bother. 0 to 4, which is e to the 4th minus 1. Does that look all right? Okay, good. So that's my area. That's what's going to go down here for each of those. So let's deal with these now. These are going to be fun. I can tell just looking at them that they're going to be a joy. So let's see. This will be 1 over, I'll write this stuff down. E to the 4th minus 1, 0 to 4, x, oh, yeah, well, we can do this though, we know how. We find someone that, Michael G, you know how to do this, don't you? What would you do to do this antiderivative? It kind of makes you happy, well, makes me happy. Yeah, integration by parts. This one's not a hard one to do. Surely you can just write down u equals x. dv is equal to e to the x dx. Let's just crank through this really quick. V is e to the x. And so that whole thing, e to the 4th minus 1 times u times v. So x e to the x minus the integral of v du. So you probably got something like that. So let me just go through, you know the antiderivative of e to the x is e to the x. So this is equal to, sorry, this is like a little bit of a mess. I've got to keep this around every single time. So this will be x e to the x minus e to the x, evaluated from 0 to 4. So you can plug this in yourself. It's not that hard. I think we get 3e to the 4th minus 1. Oh, no, it's plus 1, isn't it? Over e to the 4th minus 1. Is that what we got? I'm curious what this is on a calculator, though. Yeah, let me know if any of that's wrong. I'm just going to crank this into this calculator. 3e to the 4th plus 1 divided by parenthesis. All right, I'm getting 3.07. That look all right? So that means that the average x value is a little beyond 3. Where would that be? About here, maybe. So 3.07. Now let's see where the average y value is. So that's going to be this thing. And at first glance, you might think that's going to be way harder. Yeah, what do you think, Hayden? Oh, because I combined, I plugged 4 into here, and I got 4 times e to the 4th minus e to the 4th, which is 3e to the 4th. So if you have 4 apples and you give 1 away, you end up with 3, right? So yeah, so 3e to the 4th, and then the 1 is because when you plug 0 into this, you get 0 minus 1, but you're subtracting, so plus 1. Anything else? Other complaints? Made mistakes? I didn't, hopefully, but you might have. Okay, yeah, let's crank out this last one. Yeah, when usually the y bar is harder than but in this case it's actually easier. So y bar in this case is going to be 1 over e to the 4th minus 1, still the same area. Integral from 0 to 4 of 1/2 e to the x squared. So take a minute, see if you can do that. And like I say, it's actually easier than the last one. I guess if you don't have to use parts. That's the thing that makes it easier to me. I'll make one simplification, then I'll go ahead and see who wants to do this one. So when you have nested exponents, of course, you just multiply the exponents together. Nice and easy. And then Daniel, you know what the antiderivative of e to the 2x is, don't you? Very nice. So we have this 1/2 here, but then you have an additional 1/2 from doing substitution, which Daniel is so quick he could do it in his head. But if you can't do substitution in your head, don't be afraid of writing u equals 2x, du is 2dx, and then do the algebra that you need to. So, but that 2 there, the second half, this one is this, the second 1/2 came from Daniel's doing substitution. Let's plug and chug these numbers. How much time do we have? Oh, plenty of time. Okay, so we have time for the final one. So this is going to be, what is this? 1/4. Let's do this. 4e to the 4th minus 4. So I've combined, so just so I can explain, those together went down here. And then in the numerator, I'll put e to the 8th minus 1. There it is. Ooh, oh, tempting. I'm going to do it. This is fine the way it is, but I'm going to, here. Those are equivalent. If you want to know why they're equivalent, you do the algebra. But let me do this. E to the 4th minus 1. E to the 4th plus 1 divided by 4. So I'm getting 13.89 or 13.9, 13.8995, close enough to 13.9 as my answer. So let's see, where is this on my little graph? 13.899. So that's going to be about here. Let's see, that's 12, maybe right about a little bit above that line. So right about here is the center of mass. So there it is. There's the center of mass, the centroid, whatever you want to call it. Center of mass, centroid. I'm happy either way. I know, there's a slight difference, but it's the balancing point. You could put this thing on that. Okay, so we're happy with this, reasonably happy, maybe not happy with my algebraic expression here, but I'll let you leave that as an exercise if you want to. You can try to figure out why that is the same as that. But let us go on and do the final example, and then we'll be done for the day. Let's find the centroid of this region. So I'll let you set this one up completely, but I'll just say do the area first. So you have these two cubics. Well, one of them is really a cube root. I'll zoom in here in just a minute to make it easier to see. Okay, this should be better. Freeze there. Okay. All right, let's see how we're doing. I know you're not done, but I want to get it set up. Andrew, what did you do to find the area? What does that look like for you? Okay, very good. And that's going to be your integrand. Nice work. And you're going to integrate this over that whole region. I suppose I need to know my limits for this thing. Americo, do you know what the limits are for this? 1 to 0 or 0 to 1? 0 to 1 probably makes more sense. How did you know it's 0 to 1? The graph, okay. Okay, yeah, I figured. So let's do it the right way though. So you correctly identified the fact that this second thing is y is equal to x to the 1/3. And so we want x cubed to equal x to the 1/3. Figure out what the algebraically, just to be sure, because who knows, maybe I didn't draw that. Those don't look quite right, do they? I don't know, it looks a little funky. So I don't believe myself, at least my graph. So let's see, how am I going to do this? Let's cube both sides. So I have x to the 9th is equal to x. And that gives me x to the 9th minus x equals 0. Uh-oh, things are getting ugly. X times x to the 8th minus 1 equals 0. And that gives me x equals 0, or x is equal to plus or minus 1, right? Because if x to the 8th equals 1, then x equals plus or minus 1. So I guess this thing would be down here as well, probably the same sort of a shape, but I only want the part that is in the first quadrant. That's why I specified that. So yes, you were right. It is 0 and 1, but it's always good to double check algebraically, especially if I tell you to on the test, which I probably will. Okay, so we've got our limits. Now we can do our antiderivative. By the way, I noticed on the last quiz, some of you are still having a little trouble with your basic antiderivative rules. So go ahead and actually do this. Jot down what you think the antiderivative is for this. I'm pretty sure everyone's going to get the second piece correct, but it's that first one that I'm a little bit worried about. So take a minute, see if you can get the antiderivative. Well, Eli, do you have an antiderivative?
Yeah. 34 x to the 4/3 minus 1/4
Beautiful. All right, so let me review, because this was a little bit of an issue on that quiz that I just gave back to you. And that is that when we're integrating something like x to the, I don't know, let me make sure, it's the fractions. The fractions are problems, aren't they? So if you have something like this, x to the 1/2 dx, then what we're going to do is we're going to add 1 to that power. It becomes 3/2, and then divide by that power. Now, there's a temptation to just go and say, well, we're just going to end up flipping this. It's the reciprocal, and that is true. It is the reciprocal, 2/3, but it is safer, especially if you're prone to making mistakes of this sort. It's safer to just write it as x to the 4/3 divided by 4/3 and then sort things out later. This is correct, by the way. Well done. But just want to make sure that you have a chance to get it wrong now when it's safe, and then that way you'll get it right when you have the next time you do it on a quiz or test. Okay, so next we'll plug and chug these things. This is easy. This will be 3/4 times 1 minus 1/4, and then minus 0. Okay, I've done that. So I'm getting 1/2. Is that what you get? 1/2? Sounds pretty good. It looks like it's got an area of 1/2, doesn't it? Okay, very good. So we've got the area. Next, we want to find x bar. So go ahead and do x bar. Set it up, and I'll find someone. So I'll get you started. We all know that it's going to be this, but it's what goes in there that matters. We'll take a minute. Well, Ethan, what do you want me to put in this integral? All right, sorry, I'm rushing you here. Oh, I left off something. You go ahead. I'm going to fix my thing isn't correctly written here. Some of you might have noticed. 1 over the area. I forgot to put that in. Okay, so when you're ready, and you don't have to have it simplified, you can just tell me what to write. Okay, here, I've got it right here. Look at this. I'll just shove it up here. There it is. So since it's the X bar, you just throw an extra X in there. So that's the first thing. X, very good, times. It's okay, it's the functions. So now you just, what are the two functions? Those functions, yeah. So we'll just do the top function minus the bottom function. So very good. So we'll just do that. So let's go ahead and crank this in now that we've got this. And once again, we have an opportunity for you to get something wrong if you're of that sort. You know, it's much better to do it now than when it's on a test or a quiz. So that's why I'm very big on making mistakes in safe spaces. So in this case, we have x to the 4/3 minus x to the 4th is what we get when we get, and by the way, 1 over a is 1/2, so 1 over a is 2. So that's why I have a 2 there. So go ahead and do the antiderivative. Here's another opportunity to get this wrong. Do it now if you're going to get it wrong somewhere so that you can do it right when you get to the test or the quiz. Where are we on our reign of joy here? Michael in the back. Michael H. Michael, can you do this antiderivative? Let's hear it. So I always do the exponent first. Do the exponent. What? The x to the 4/3. It's a hard one. So what's 4/3 plus 1? So you're doing 4/3.
Oh, that one, sorry.
Yeah. Okay. Yeah. Let me do that one. That's encouraging. Just a minute. 1/5 x to the 5th. Good. Okay. Very good. Yeah. So yeah. That's sorry. I got it. You did it perfectly. Yeah. This one's the easy one. But yeah, I always find that if I have a hard thing like this, it's much easier for me to think in terms of what's 4/3 plus 1. Deal with that first, and then I'll deal with whatever the coefficient is. So well done, though. Now let's go ahead and plug this in. So this is equal to 2 times 3/7 minus 1/5 minus 0 because of the lower limit. Sorry, it's a bit of a mess there. So what's this going to be? 30/5? Lovely. 15 minus 7 is 8. So 16/35 I think is my final answer for that one. So that's the average x value. Whew. Do we have time? We do. Let's get this out of the way. Let's set up the average y value. Okay, so average x value was 16/35. Average y value. See if you can do it. I will write the 1 over a in for you. So see if you can remember what that stuff is, and I suppose I could even put the formula back up on the screen in just a minute. But I'll give you a minute to see if you can get it. I'll find a volunteer. This is the hardest of the bunch. So Hayden, I think you're up to the task, aren't you? What do you got for this one?
So I did 2 times the integral of 1/2
All right, I'm just modifying it slightly for us. So here, yeah. So it's just to explain. Here's the slight difference. So I'm just going to show you a couple things. First of all, here is the formula if you just have a single function. But we had 2 functions, if you remember, when we did the sine and cosine. And so when we had the sine and cosine, what happened was we ended up doing, where is this work? Where is it? It's down here. There it is. So we ended up with this. Notice that you ended up with 1/2 of the top function squared minus the bottom function squared. So if you have two functions, it is easier. You end up doing 1/2 times the top function squared minus the bottom function. I'm just going to write it like this. So yeah, that's if there's two functions, this becomes that. Another way of looking at it is you're just going to do whatever's on top, which is 1/2 times the top function squared, minus whatever's on bottom, 1/2 times the bottom function squared. But yeah, it does end up being arithmetically easier, at least in this particular case. So here's what we're working with. Sorry, it's a little bit of a mess. Let me clean it up. Y bar, the 1 over a is indeed 2, because 1 over 1/2 is 2. So then there's 1/2 times x to the 2/3 minus x to the 6th. So that's what you should be working with. Final chance for you to, let's cancel those. 0 to 1, x to the 2/3, x to the 6th. So hopefully you're getting all of your mistakes out of the way with these fractional exponents, but this is your final opportunity. Let's see how you do. See, you're not here to do this, but Braden is. Braden, can you do this antiderivative? Nice. So here again, my strategy, and this might be what Braden did, I don't know, is I deal with that exponent first because it's so hard. 2/3 plus 1, if you need to, write it down. 2/3 plus 1 is 5/3, good job. And then you can divide by 5/3, which is the same as multiplying by the reciprocal. And then, of course, we're all good with that, I think. Now we're almost done with this because now we just have to plug in our numbers. You get 3/5 minus 1/7 minus 0. Let's see, 3/5. Oh, this is another one. We're going to have to use 35ths. So 721 minus 5, 16. Wait a minute. That's exactly the same thing I had over there. Actually, that makes sense because this is symmetric. But the center of mass, or the centroid, will be at 16/35, and 16/35 will be the center of mass for that thing. Okay, I think that's enough. There may be some other, I don't think that there's anything much more than this, but if there is, I'm sure you can figure it out because you have the book and you can read. So I trust that you can do that. If there are other questions, though, stick around and we can talk. Otherwise, have a great weekend. It's a beautiful day.